Okay, guys, I'm just going to do a bit of live coding. What I've just been doing with my rather bad geometry file is adding line rendering. You may have seen my blog post about this. If we actually launch the engine, which has appeared off screen, which is a bit annoying, skip to this camera. Where is it? There we are. So we can see I've got a line renderer drawing a couple of lines. And one of the uses for this was actually to allow me to better visualize certain positions, rotations, and orientations in the engine. But one of the things I noticed was I couldn't tell left from right. So I'm actually using the mouse to move around here. I couldn't tell, those vertices over here, are these actually validly set? Are they truly going to be correct or not? Or I just couldn't work things out. So one thing I was doing was adding in the line renderer and the what I call a flag. What I wanted to do is expand this and add the dot product in. So I want to be able to tell, instead of my hard coding the left and right, I wanted to add them in myself manually. I have some notes off screen that I'm going to refer to, but let's do this live. So I'm using GLM, so I'm going to use Vec3 and Vec4. So Vec3s are going to be my positions and Vec4s are going to be my colors. So let's have a center. And we know that for the center of this geometry or this model, it's 0, 0. That's where I want the center of every piece of geometry to start in my engine. Then I want to know what's directly in front of it. So think of it like a nose cone or a beak or the thing that's pointing out in front of it, the front direction. So let's actually call that the lookat. And we're going to look directly down the Z axis by a distance of 1. The only other thing I need to know for this is the up relative to these. Well, if we hold our left hand out in front of us and make the sign like a pistol almost, point your index finger, that's the Z that we've just put the 1 on. So the thumb held at 90 degrees to that finger, that makes the up direction, and we want the up on our Y for this engine. So there are 3 vertices between which we'll have 2 vectors that we can actually draw, and we can start to draw them. So let's actually create my renderer geometry, raw geometry. Let's call this axis, because that's what it's really going to be, an axis along each of the 3 directions. Let's call this the axis. This is where my raw geometry class lets me down, because it's set up to do indices as triangles, and unfortunately we're going to be drawing lines, so we'll just pad anything out with zeros, but we need 2 lines, 0 to 1, so center to forward, which is where we'll get to, and then 0 to 2, which is center to up. The other 2 can just be 0, 0, big deal. There our indices have been set up. I'm using initializer list, which makes this really quite hard to read. The reason for that is that this is all going to go away in my engine. I don't need to worry about it. So this is vertex 0. This is going to be vertex 1. I wish Visual Studio wouldn't fudge about with my tabs as I do things. So there's vertex 2. And we need vertex 3, and that's we only need those 3 right now. So the first vertex, the second vertex, and the third vertex. And this is going to be in position center, and it needs a color in a moment. So let's do some colors first. So let's have GLM vec for red 1 0 0 1, GLM vec capital V, so lowercase v vec for that would be green 1 0 1 0 1. So that's RGBA, red, green, alpha. GLM for vec for blue would be 0 0 1 1. And I'll need a third fourth color somewhere else. So let's do a vec for. Let's do a light blue. You have to forgive me for being quite vague because I'm actually really tired right now. 0.9, and then blue has to be the strongest color we've got there. So 1 and then 1 for alpha. So that should be a lightish blue, if memory serves. Red and heavy green, but not full. Yeah, that should be a lightish blue as we get somewhere. So the center position, and then this will be red center, and the second vertex, which is, remember, out in front of us, that will be our look at, or whatever, distance from it. And this will also be red. We need to have, overwritten it's red. So that's the first set of vertices. The second vertex is not actually 0. So my code here is wrong. So we do need a 2, and then we need to go to 3 because we're going to draw a different colored line. So it needs to be center again, but it needs to be a different color. So let's do blue. Okay, so center to blue. It's screwing up my tabbing. I need to go and sort that out somewhere else. And then vertex number 3 is actually going to be, the dog's barking, up position, and then blue. So we're drawing 2 separate lines, just like you saw a moment ago. That should be, let me just make sure that builds, which it does. So now let me create a model, which is how I have things in this. So auto axis model is going to be standard, make, unique. To render a model type. And the parameters are the renderer itself to use, renderer, and then its name is axis model. It's going to use the axis geo we just created, and it's going to be a line list. So I've only just added line list, which is why the indices above are in triangles. So I need to sort that out. So primitive topology is a line list. Okay, so the model has been instantiated, and now I need to stick it into my the renderer. So the renderer needs to know how to use the model. This could all be tidied up. I need to actually make this self-registering. Once the model type is created by the renderer is used to register it. It's all a bit, I can just stick it into the scene really. So axis model pointer, it's the scene that we're using. Register the model into it and move the axis. So the unique pointer is now owned by the scene, and in the scene itself I need to add, so let me just check that builds as well, which it does. Now the center of my scene is occupied by the cubes, the 4 cubes. So as you saw with this thing, I've actually stuck it off to one side. I'm going to do the same for the axis, auto axis position, XVE, client, which I could spell, client, object position, and then axis position. I'm going to actually move, make it a bit bigger, make it twice the size. So where we've had 1s above, so 0 to 1 for the vertices, they'll actually be 0 to 2 when they scale up, just to make them visible. It doesn't change our data. We're going to move it to the right on the screen. So relative to our camera to the right actually needs a negative number because our camera is looking negatively down the Z axis. This is a bit confusing, I admit, but never mind. Oh, and I'll lift it slightly off the 0 plane because otherwise you say Z order fightering with the ground plane. So scene, add this object, and it's called the axis object. It's using the axis model. It's at the axis position. I hate Visual Studio at the moment. Vertex shader, C shader, pixel shader. These are the pixel shader constants that we use. So this model is now added to this object. This object is added to the scene. The scene knows about whatever models are in it. So different scenes can have actually different models. And in this case, I'm adding them. So we should now, when this builds, which it has, going to launch on the wrong screen. We can already see it. There it is. Look, if you can actually view that just here, you can see. If I actually slide the camera out and across, there it is. So this is the blue line. That's the red line. So that's the direction of our forward vertex. This is the up. This is all I know really about most cameras. What I'm doing now is the mathematics for left and right. This is the cross product. This is something I find magical. So how do I find the cross product? What's this 11 minutes of waffle so far all been about? Well, it's about drawing a line directly left or right of these 2 points. So the end of the blue or the end of the red. We know the center, so that's useful. So we actually take this as a vector, and we take this as a vector, and we cross product the 2 to tell us left and right. So this difference cross product with that difference added back on will give us left or right. We only need to do the cross product once to give us both directions, which is quite useful. That's what we'll do now. Just referring back to my notes because I'm not very good at this. So given these 3 positions, we'll now zoom in because this is important. This isn't just boilerplate stuff. So we want to know the cross product of the 2. Well, the first thing we need to know is the actual direction of forward. So we're going to do lookat minus center. This tells us that red line. That is that red line defined in mathematically for ourselves. Okay. We can now get the cross product. GLM cross, and it's the direction with up. So we already know. Ironically, up is already a correct vector for this. I haven't looked whether I need to do the difference of up minus center, but we will see. I don't know if that will give me the right number, but I will do it this way right now. So that's now the cross product, and I can make it const, and it actually comes out as a GLM vec3 as well. And this means I can add it back on. So the GLM vec3 for left is center minus the cross, and the GLM vec3 for the right is center plus cross. Okay, so now we can add 2 more lines. This is why I had the blue and light blue ready to go. So let's do 4, and this is center in what color? Green. To 5, which is going to be left, also green. And then we'll just draw that first of all. So we've already got the indices for it, so 4 and 5. So we're now drawing a line 0 to 1, a line 2 to 3, and a line 4 to 5. We don't need to change any of the model stuff. This will all be handled for us by the raw geometry classes I'm using. And second, I'm going to sort out all my indices. Opened off camera. So we were drawing left. You see it's here now straight away. Let's just zoom out of it, move across. So we've got red, just here, red, center to forward or center to look at. Then we've got blue, which is center to up. And then we've got the green, which is literally center to left. It's gone left. So if we want to do right, kill the application a moment, and we do 6, which is center, light blue. Center, oh no, right rather, right, so light blue. And then on here, we need a triangle, 6 and 7. Doesn't matter for the final index. But what's the trouble here is that we're drawing, I'm drawing a line list, which has to be an even number. There are 2 points per line. So I actually need to add a 4th triangle, just all nulled out, just to make sure I don't crash. If we now run, we'll see a light blue line go right. There we go. So switch the camera. There it is. There's the light blue line going to the right. And that's the magic of cross product for me. I really, really like cross product. What I will do is I will post this video with this little snippet of code just here, just to let you see that mathematics. And that's the piece that I love. Obviously, cross product is itself a complex thing, but I just love this little ditty. That's all. It always makes me smile when I see it. And I hope you enjoyed this little ramble by me. I'm trying to get back into doing more videos. I've had a fair bit of a hiatus. You've seen little clips of the animals, the horses, the dogs, but technology is always in the background. I'm just so busy with it at work for real that when I get home, I like to do my own little thing. This engine is my own little thing. It's a great playground for me to go and check things and do things. Rotations and vertex stuff is really where I'm at the moment. I'm going to tidy up the geometry and some of the rendering I've got, and I'm going to I can actually import a custom model format from Blender. So I've got an exporter written in Python that I can then import that model into the engine, which in fact is exactly what, if I can grab the mouse, exactly what these cubes are. These cube objects are added to the scene and they're given different bits and bobs. The line rendering is actually going to be part of what I'm trying to do with the engine. So what I want to be able to do is highlight edges. So this is all very simple stuff, but I don't want to do it in the shader. I want to be able to sort of have separate objects with like a ghost of itself somewhere else. It's just an idea. It's just something I'm playing about with. And so there'd be a wireframe or a motion blur of the wireframe coming to the point, and then it would disappear. Maybe in case I can do that in the fragment shader, I need to experiment, basically, don't I? Speak to you soon. And if you do like and subscribe, I'll promise to do more. Thank you.